Thank you, Marsha. Hi everyone, and welcome to this webinar, which is about CAD creation and Boolean operation in Nullspace Prep. And in this webinar, we'll talk about creating the CAD parts and Boolean operation for the patch antenna example that operates at 16 gigahertz. So this example will include different parts. So we'll include the patch and the substrate for the patch, and also we need the feed parts for the antenna, which will use a coaxial connector to feed the antenna. So now we can see here the Nullspace Prep window, and we want to start by creating the substrate, and we want to also set the variable names and values for the substrate. So here on this panel, we can see the variable name and the values. So we can go ahead and start setting the variable for the substrate. So we want to use, for the thickness of the substrate, we want to use a variable name called sub_h. And we set the value to 31. And the units that we are using in this project is set to mil. And we are using a standard substrate with 31 mil from a Roger manufacturer. So, and we want to also define a variable for the width of the substrate. So we'll say that sub_w, and we set that to 787. So now we have defined the substrate variables, and as you might notice on the command line panel, you can see that two commands popped up. So you can see that how you can also get these commands and use the command line to define the variable. So the way it's defined to command line, then you need to use the pound and brackets and set the name and value for the variables. Okay, so now let's go to command panel, and then we can use the mode geometry and entity. You can select volumes, and from the action we can select create, and we can select brick. So if you want to refer to a variable name in these boxes, then you have to use the brackets and write down the variable name. So we say sub_h. We want to align the thickness with the x direction, and for the height and depth, we want to set the same value. So we want to have a square substrate. So we say sub_w, and you can go ahead and copy and paste that. Okay, so now we have created the substrate, and then you can see from the model tree, you can see that we have volume 1 right now. If you select that and right click, and this is a good tip to do when you create an object. It is recommended to rename that and give it a good name. So you can use that when you want to apply a different operation on that object as we go later on. So now we have named that, and then one thing we do before we create the patch on top of the substrate. So we want to align that. So if this is the top of the substrate, this side, then we want to align that with the origin of the coordinate system. So let's go ahead and move the substrate to the origin of the coordinate system. So from the action, you can select transform, and now from the list, you can select move, and now you can see that the ID here, now I've selected ID 1. You can either use the IDs, or you can also, since we already named the volume, now you can say substrate. So now I'm referring to the substrate volume. And you can go ahead and then select which offset you want in different directions. So we want to move that on the X direction by half of the substrate thickness. So we say minus _h divided by 2. So if you press preview, then you can see how we'll end up and then press apply. So now we have done the substrate creation, and then we want to create a patch antenna. So instead of the volume, we can select surface, and from the action create, and from the list of the menu, we can select rectangular. So let's go ahead and also set the variable for the patch. Let's go ahead and write patch underscore W and set the value for that 187. So the values that we set for the dimensions are taken from the simulated result that we have, that we perform at 16 gigahertz. So let's go ahead and then put that in the box for the widths. So let's write down patch underscore W, and you see that here it says optional. So if you want to use the same dimension for the height, then you don't need to type that again. So and we want to have it on the choose the X plane and press apply. So now you can see that we have created the patch, and we can go again from the model tree and then menu, select the volume and rename that to patch underscore volume. Now I want to mention about the commands line that is popping up here. So now you can see that we have created renamed the patch volume, and then we created the patch. We assigned the values for that. So you can access that in the history. So if you select the history, then you can see only the commands that we did so far. So you can see that what we have done so far. So one really good tip is to just copy those and then open the general editor, new file, and then paste that in the general editor. So this is the best way to modify a parameter's value or modify some part of the project. So right now you can see that I have created the variable names and values, and then created the substrate, did the move operation, and the same thing for the patch. So here you can see also preview. You can delete that, so that will not do anything. So if I run this again, so then you will see that you will get another object. So right now I have not put the reset in the beginning. So if I put the reset in the beginning, then that will reset the CAD. So now if I run that again, now I've recreated the substrate and patch. So now we have done that. Let's go ahead and then create the ground for the substrate. So we want to have the ground on back of the substrate, so on the bottom of the substrate. We can use the same method that we use for the patch. So we can go ahead and then select rectangular. And then for the width, we want to say it should have the same width as the substrate width. So we'll say sub underscore W and press apply. And if you click on the model tree, then you can see that we have created this, and then we can also rename that to ground and then give it a short name as GND. And we want to move that to the back of the substrate. So let's go ahead from the action transform, move. We can select the ID directly, or there's another way to do this. So since now I have named the volume GND, so I have to refer to the surface in that volume. So the way you can do that in the Nullspace Prep, so you have to write the surface ID in volume GND. So that will refer to the surface in that volume. And then we want to offset that by the substrate thickness. So underscore H, if you press preview and apply. So now we have moved that to the back of the substrate. Okay, so now we have created the ground, and then next step is to create a connector for fitting the antenna. So the connector includes the inner conductor and then the outer part. So we want to define the parameters for this connectors. We want to first set the length of the connector. So we say coax underscore L and set that to 100. And we want to also set the radius for that. So coax underscore R, and we set that to 20. And for the inner part, we can define a variable called p underscore R, set that to 6. And now this is the part that we want to place the ports between the inner conductor and the shell. So the way that ports are defined in Nullspace EM is by voltage sources. So we need to place the voltage source between the shell or the ground of the connector and the inner part. So we need to define also the port width also here. So we can say VS underscore W as a parameter for the port width, and then set that to the diameter of the inner pin. So we say pin underscore R 2 times. So we have done that, and then now we can calculate what would be the length of the inner pin. So the inner conductor will go through the substrate. So we need to include the substrate thickness and plus the coaxial, the connector length plus coax underscore L. And we want to remove the part and have a gap where the port will be located. So we remove the port width, so VS underscore W. Great. Now we have the parameters that we need to create the pin. So we go back and select the volume, and then from the action, create, and from the list, instead of the brick, we want to use prism. And the main reason that we are using a prism instead of a cylinder is that to simplify the meshing, and also electrically will be very similar to using a cylinder for this example. So we want to simplify the process. So now we go ahead and select, put the size. So we say pin underscore L. And we want to use a hexa. So we say number of sides, we set that to 6. And we want to set the radius to pin underscore R. Okay, let's go ahead and then press apply. Now you can see that we have created this prism, and then we can go ahead and do the same thing here. Select the volume and rename that to pin. So right now you can see that we need to move it to the right location. So first we need to rotate that and then place it to the feeding position. So from the action, you can go ahead and then select the transform, and from the menu, instead of move, select the rotate, and you can select a volume in this case, or the name of the volume. So we want to rotate that 90 degrees on the x-axis, and then press apply. And next step is to move it to the feed location. So to be able to do that, we also need a variable name for the feed offset, and we call that feed offset. And that will tell us how much we need to offset compared to the patch width. So we set that value for that. And we can go ahead and select volume, select the volume ID, and we want to go ahead and first offset that to on the X direction. So it should go within the substrate, and we want to also offset that on the Z direction. So let's go ahead and then apply the correct offset. So it will be half of the length of the pin, and on the Z axis, we want to first move it to the edge of the patch. So it will be patch underscore W divided by 2. And then we want to offset that by feed offset and apply the patch widths as well. So if you press preview, then you can see that how will end up. So, and then if you press apply now, then you can see that now it's touching the patch and then it goes through the substrate and to the end where will be the end of the connector. Okay, so now we have created that, and then we have to do a similar thing for the outer part. So we can go back and select the create trace. Instead of the pin_L, we set that to coax_L, and the same here. So we say coax_R, press apply. So we do the similar process from the action transform, select the volume, and first we want to rotate that. So we have already the angles, and just press apply, and then now we can move that to the right location. So we can apply the same offset for the Z and compensate for the X distance. So we want to move by, so this part we need to place it on back of the substrate where we have the ground. So we want to move it by to the substrate and also offset by half of the coaxial lengths. So if you press preview, now you can see where it will end up. So now we have done this part, and then now we can go ahead and create the feed face or the feed surface that we want to add the port later on. So from the menu, you can select the surface in this case, and then rectangular. So we want to set width value. So we say vs_w as we define, and we want to select the Z plane in this case. So the port will be located between the inner and the outer shell. So if you press apply, now we can see that we have created this surface. We can go ahead and also do the same thing here. So we can rename that to feed. And we want to move that to the right location as well. So let's go ahead and from the action transform and select the surface here. And we want to move that to the substrate and offset that by the coaxial length and bring it to the port location. So we need to offset, bring it up by the half of the port width. So for the Z distance, we can go ahead from, it will be the same offset for the that we did for the pin and the coaxial ball. So we can go ahead from the history, you can see that here that I have that value already. So you can go ahead and then copy that and then paste that here. So if I press preview, then you can see we'll end up between the inner contour to outer shell. So now press apply. Now we have created the feed. One last thing we need to do for the feed is to, we need the way that ports are assigned in Nullspace is they are assigned by the positive and negative surfaces. So we need to split the feed into two parts where we can assign the polarity. So the top part we need to assign it as a positive and the bottom as negative. So we can go ahead and select the feed from the menu and right click on that and isolate. So that will only show the feed right now. And you can select the surface and then you can say modify surfaces. So from the list, you can we can select the split surfaces, and the method we want to use the direction of curve to define how to split surface. So we can select the surface ID and direction of curve ID. So you can select the curve that you want to cut it along the y-axis. So you can select this curve And if you press preview, then you can see how it will be split it. So press apply. Now we have split it in two parts. Great. Now, one last thing that we need to do before we start the Boolean operation, we need to, so for the meshing part that we do later on, we want to have the same mesh on the bottom of the connector as we have on the pin. So we want, the way to do that is to project the inner conductor part on the bottom of the coaxial. So we can go ahead and from the action select create, and we can use the projection method. So project. So we want to project the select the surface ID that we want to project. So like you have to select that one. But now it's this surface is selected. So if you right click and then say, I want to select other. Now you have different options. So you can go ahead and then see, yeah, now I want to select the ID that has value of 10 and select that. And I want to select the surface that I want to be projected on. So I want to select surface ID 18 and I want to imprint that. So let's say apply. Now we can see that we projected the same surface here. So then we'll get this similar mesh when we do the meshing on the bottom and top part. Great. Now we have done all the CAD creation part. So we want to go ahead and then do the Boolean operation on different parts. So the reason we need to do this Boolean operation is because if there is an overlapping of volumes, then we need to subtract the overlapping parts. And that's really important for the measure to know that if there is overlapping, the measure will try to mesh those parts 2 times and then we'll create an invalid mesh. So that's why the Boolean operation are really important to do before we step into the meshing part. So we can select from the entity volume and from the action you can see this icon called Boolean, and we want to select the subtract. So we want to subtract different parts. So we can start by, we want to subtract the coaxial part from the ground. So then to exclude the coax part from where it's overlapping with the ground. So we can say the first volume A would be the ground, and then we want to remove the coax part. And we want to keep so we want to say select keep originals and we want to keep the B, so which will be the coax. So now we have done that. So if you select the ground, yeah, so now we got an error that, okay, it says that it didn't recognize the coax. So we forgot to rename the coax part. So let's go ahead and then right click on that and then say coax. And then do the same thing. So we want to remove the coax and then press apply. And if you select the ground, then you can see that the coax has been cut from the ground. Okay, so now we want to do a few more subtractions. So we need to remove the pin from the substrate. So we say substrate, and then we want to remove the pin, and we want to remove the pin from the coax as well. So press apply, and the last thing we want to do is to remove the feed part from the coax. So we put B as the feed and then press apply. So if I want to show, let's say I want to show the coax part, then you can see now we have removed the overlapping parts. And if you press all visible, right click and all visible, then you go back to the same view. Now you can see also on this toolbar on the top part, you can see different modes for showing the parts. So I have selected transparent. Now you can see that I can see through the objects. So if you select next to this one, then you can see that it shows as a solid. So it's nice to have it as transparent, then you can see inside the different parts. Okay, so now we have to do just few more things before we are done with the Boolean operation. So we want to also do the imprint and merge all the volumes. And this is the best practice to do once you're done with all the CAD creation. So imprint and merge will also, as the same reason that we mentioned, that for the measure to know that if there is an overlap, then we need to imprint all the volumes and merge them together so that the measure knows that there's no conflict on the curves or surfaces or volumes. So the easiest ways to do that is from the command line and then say imprint volume all. Now it's updated volume 1, 2, and 4. And you say merge volume all. So it will merge all the volumes. Yes, and the last thing that we need to do is to add all the surfaces in one block. So that's necessary also for the Nullspace EM to know that it needs to know the way that all this for the measure that needs to know that everything is added into one block. So we can also do that through the command, or we can also do that through the GUI. So from the GUI, then you can select this orange icon, analysis group, and then from entity choose block, and from action you can select create block, and you can give it a block ID 1 and select surfaces and put all. So that one means all the surfaces, and press apply. So that will give all the, you can see that block 1 add surface all. So that added all the surfaces into one block. So now we have done all the parts for the CAD creation and Boolean operation. So let's go ahead and then select the history again. And we want just to copy all that we have done and then paste that in the general file. And we can go through it quickly and save that. So let's go ahead from the beginning that we have done the substrate, and then we have created the patch, and we created the ground, and we can remove this preview, and we have created the pin, and we have done this operation. I'm just removing all the parts that are not necessary, so to clean up the general file. So now we have created the coaxial part. We rotated that and moved that and created the feet. And then we've done the split part on the feet. And these parts, we don't need this. So we have done those for the visibilities. So we can remove those. And we did the projection of the surface. And here we did we renamed the coax part, and then here started we did a Boolean operation, and after that we can remove these parts as well. So we removed that, and then we did the imprint, merge, and block 1. Add it all in one block. So if I just run this again, then we will be able to get the same thing. So we can go ahead and save this file as patch CAD. And then later on, for the next webinar, then we will open this and load this, and then we'll start to do the next part, which will be the meshing of different parts and material assignments and how to do also how to create a material library. So that was all for this webinar. Thank you.